So now we're going to talk about the case 4, which talks about the hydrolysis of salt of weak acid and weak base. So first of all, let's make the salt. We have a weak acid and we have a weak base, which forms CH3COO and H4 plus H2O. So C concentration, it will dissociate to form C, and CH3COO and H4 will form a CH3COO minus plus NH4 plus, and that C will form a C over here and C over here. Initially it was C and it will form C over here and C over here. Now, as I told you, there are 4 steps while deriving the pH of the salts, hydrolysis of salt. First is general hydrolysis reaction. Now, what is a general hydrolysis reaction? We know both are its weak form, like acetate ion and NH4 plus ion. Both are the weak form and it will form CH3COOH plus OH negative, and H2O it will form CH3COOH plus it will form NH4OH plus H positive. When both of these are being added, it will form CH3COO negative plus NH4 positive plus H2O. Right, I'm writing 2H2O, then H2O and OH minus will cancel and will form CH3COOH plus NH4OH. Now we have to write the KH. KH simply CH3COOH into NH4OH over the CH3COO negative into NH4 positive. So this is the overall general hydrolysis reaction. Now if we go to the second step to derive it, the second step is relation between KH and KW. Now KW we know it is H plus into OH negative, and Ka is CH3COO negative into H positive over the CH3COOH, and we have the Kb. Kb is NH4 plus and OH negative over NH4OH. Now term this equation 1, this is equation 2, this is equation 3, and this as equation 4. Now, as I told you how we write KH in terms of KW and other constant. So it's KH equals to KW. Now here we have Ka and here we have Kb. So it will be Ka into Kb. I have told you the trick to calculate the relation between, to find out the relation between KH, KW and Ka and Kb, whatever we have. So here, or you can do it like equation 2, you divide it by 3 multiplied by 4. So it will be KH equals to KW upon Ka into Kb. So this will be the equation number 5. Now as all we have third relation between KH and H. Now the relation between KH and H. So CH3COO negative plus NH4 positive plus H2O, hydrolysis of these are taking place, and will form CH3COOH plus NH4OH. So it is C. So it will form C into C minus CH, C minus CH, and it will form CH and CH. So KH we write as C square H square upon C square into 1 minus H square. So we could write it as H square upon 1 minus H square. So that is the relation between KH and H. Now let's give this equation as equation number 6. Now, if we go on the fourth step during the calculation, so if we write the fourth step, derivation of pH. K we know CH3COO minus into H plus upon CH3COOH. So if we write Ka, what is the CH3COO minus upon CH3COOH? We know it is C into 1 minus H. H plus we write in the same. It is C into H. So concentration of H plus equals to Ka into H upon 1 minus H. Now from the previous equation, it is actually 1 minus H whole square. From previous equation we can calculate H upon 1 minus H equals to under root of Kh. So Ka into under root of Kh. So K, what is the Kh? Kh is Kw upon Ka into Kb. Now K into Ka we get H plus equals to Kw into Ka upon Kb. So here we can minus log of both sides, pH equals to 1 by 2. pKw plus pKa minus pKb. So here we got the value of pH. Remember that this value of pH doesn't depend on the concentration of salt taken. Remember, it doesn't depend the concentration of salt taken. It depends only pKa and pKb values. Now, as we have given some question, I'll appreciate you to pause the video and try to answer it by your own. So we have given Ka and Kb value and we have to calculate the pH. We know in case of weak acid and weak base, the salt hydrolysis, the pH doesn't depend on the concentration. So here pH equals to 1 by 2. pKw is 14. Now pKw plus pKa minus pKb. Plus pKa is 5 minus pKb is 5 equals to 7. 1 by 2. Here pH equals to pKw 14 plus pKa. pKa is 4 minus pK is 5. So here it is 6.5. It is acidic in nature. Right? K is less, so it should be acidic in nature. So by formula it is also coming to be acidic in nature. Now here pH equals to 1 by 2. pKw is 14 plus pKa. pKa is 6 minus pKb is 5. So it is coming out to 7.5. So it is basic in nature. So point to remember in that specific case, that degree of dissociation of and pH of solution of salt of weak acid and weak base does not depend upon the concentration, that is, it is independent from dilution. So it is independent from the dilution. How much you want to dilute, the pH will remain same.